is an astrophysicist from Northern Ireland who discovered a type of star known as pulsars because we detected pulses of waves. No, not that type of wave, but electromagnetic waves. Waves are described by their wavelength, with longer waves having less energy than shorter wavelengths. You can see a small section of the electromagnetic spectrum in the form of visible light, the rainbow. For our experiment, we're going to use infrared radiation to measure temperature, but in reality, pulsars emit radio waves which have very large wavelengths and can travel great distances. Once we've reached the moon, we're going to need to build a base to protect us from temperatures ranging from minus 130 degrees to a sweltering 120 degrees. To make sure we're protected from these, we're going to need to know what materials to build our base out of. We can demonstrate thermal conductivity using something like a thermos. On the inside we have very hot liquid, but I'm still able to hold it comfortably from the outside. The conductivity of the material would determine how fast energy and temperature is transferred from the inside of the cup to the outside of the cup. Let's find out how good these materials are at thermally conducting and which ones we might be able to use to protect us from the extreme heats of the moon. For this investigation, you're going to need samples to be tested, a heat pack, cool pack, and an infrared thermometer.
Have you ever been to Disneyland?
Firstly, we need a table with columns for materials, initial temperature, temperature after 1 minute, and temperature difference. And don't forget to include your units.
Affirmative.
That was definitely an e-ticket.
Roger that, Sally.
Next, we need to activate the cool pack. We do this by breaking and twisting, which initiates a chemical reaction in the cool pack, which we know as an endothermic reaction, meaning it takes in energy from its surroundings. We're going to be measuring temperature using an infrared thermometer. To use these, turn them on and pull the trigger whilst pointing at an object, and it will tell you the temperature on the screen. Take a sample, place it on your cold pack, and point your infrared thermometer at the sample. You can see on the screen it measures the temperature for you. The sample I've tested is copper, so I need to make sure I record my results in my table.
Discovery, go at throttle up.
Discovery, roger, go at throttle up. Discovery, roger, go for deploy.
The initial temperature I recorded was 15.4 degrees Celsius, and the temperature after 1 minute was 14.3 degrees Celsius. I now need to calculate the temperature difference. To do this, I need to take the temperature after 1 minute away from the initial temperature. So I get a result of 1.1 degrees Celsius. Repeat these measurements for all of your samples. And remember to repeat it with your heat pack as well.
Hola, amigos. Felicitaciones a Mexico y especialmente a mi amigos de Guaymas.
You've now finished your investigation into the thermal properties of these materials. Which one do you think we should use to build our moon base to protect from the extreme temperatures on the moon? It's worth considering that this is not the only thing we need to think about when choosing materials. What other things need considering to protect on the moon?
Welcome home, Columbia. Beautiful, beautiful. We're going to dust it off first.